All right, so today we're going to be looking at the substrate system in Unreal Engine. And the goal of this tutorial is to provide you an understanding of the building blocks of this new system and how we can use Substrate to create a mixed material with the previous errors that we would typically see in a PBR renderer. So some of the learning objectives are going to be to understand the building blocks of the substrate system, identify the parameters Substrate uses for its materials, differentiate how substrate materials could have their textures authored compared to their legacy counterparts, and then finally to create a mixed conductive and dielectric material, so a metal and non-metal material, without having all the common errors that we would typically see when doing that in a PBR renderer. So to get things started, I'll need to make sure that Substrate is currently enabled in my project. So you can do that in the project settings and just do a search for Substrate. You'll find four options here. These Substrate Materials Beta, this is one that we want to turn on to have Substrate active in our project. Just be aware that it is going to try and convert all your current materials that you have in your project into Substrate materials, and you won't be able to go back. So if this is something that you want to experiment with and try out, I recommend copying your project before turning this on. These other two options here you can also turn on. They provide a couple of more options for us once we are working in the editor. This last one here, it does add a little bit more overhead than we need to, so unless you're actually trying to optimize things and kind of debug certain things, you can leave this one turned off to be a little bit more resource friendly on your computer. So once that's turned on, let me just clear out some of this. So once Substrate is enabled, if I go and create a material like I normally would just by right-clicking and choosing Material, when I enter into my Substrate material, I'm going to see that it looks a little bit different than the legacy options. So Substrate is essentially a framework that's built around three concepts. Slabs, which is what we use to represent basically the matter or the medium of the material that we're working with. We have operators, which manipulate the pieces of that matter. And then what we would call like a tree, essentially, which is basically how one material can branch into another material and how they all kind of layer and stack together and how they're all kind of arranged respective to each other. So what we're seeing right now looks a little bit similar to the legacy version where I have essentially a result node, right, where I can change my blend mode from opaques to translucents. This should look fairly similar to what you may have been coming from the legacy version. And then it's dropped down this node here. And it's done this because this is what it would use to try and convert any of your legacy materials into this new substrate material. So if you had a base color, metallic, specular, roughness, normal, etc., it would just plug in those maps here and try and make the conversion automatically for you. For better or worse, depending on how complex your materials are, but it would try and do that. So this is essentially just like a function or a helper node to try and convert your materials for us. I'm going to go ahead and get rid of this, just so I can drop down what is going to be one of our building blocks when working with substance, and that's going to be a slab. So substrate slab, and this is essentially our medium, our kind of our material itself. Now, a slab has a couple of different properties, and so a slab is a building block for describing the piece of matter. The slab actually has a kind of a top layer here that is called the interface. Okay, so if we just imagine our surface looks, something like this, right? It's full of kind of micro-faceted, facets, essentially. It's just a field of different edges that is, defining certain properties. So this is the this part here is the top interface. All of this underneath, right, this part here, this is the actual kind of medium that we are working with. So that's the material itself. Now this part up here, which is the interface, this is going to be defining the separation between two media. And this is what gives us our parameters and properties, such as our roughness, our anisotropy, our normal, our fuzz, our glint. That top interface is really what's defining those properties. So, basically, these properties here, and our secondary roughness, fuzz, glint, right? This is all being defined by how light reacts to this kind of interface. As light comes down, right, it's going to hit this angle and kind of bounce back. This is going to hit here, and this is going to kind of bounce out this way. This light will bounce here and kind of just bounce straight up, right? Based off of this microfaceted facets of this interface, we're going to get different roughness values, fuzz values, etc. So you may notice that the reflectivity of the slab interface is done a little bit differently than the other approach to materials that Unreal was using in the past. And you'll see that I now have a F0 and F90 property. So you may notice that the reflectivity of the slab interface is done a little bit differently than the other approach to materials that Unreal was using before, where it had a metallic channel and the diffuse map, or the base color, and the metallic map kind of worked in parallel to kind of create a metallic looking object to work with the reflectivity. Well, now we are working with a F0 and F90. So if we take a look at this, and I just make kind of a color like so, and I plug this into my F0, and I plug my slab into the result, and I just give myself a pretty low roughness. So the F0 is describing when I am receiving the normal kind of right back at me. The F90 is the normal at kind of grazing angles here. And we can use this for kind of artistic approaches, really, to kind of give ourselves some extra color around the edges on grazing angles, like so. Right, so we can see that we are able to get this kind of blue color just on the grazing angles. So a couple of new improvements that we have in the substrate system is the ability to have a secondary roughness. And this allows us to have a second GGX lobe mixed with the primary to kind of give us, like a clear coat effect, which is really nice to have that kind of extra level of roughness that we have seen in other programs, such as, say, Marmoset Toolbag. We also have a fuzz property now, which can be super helpful for cloth. And it's really nice because it's always on top of the specular lobes, and they have separated roughness and albedo properties, which is quite nice to be able to have that control. We also have the ability to have these glints, which are controlled by density over a UV parameter, and this is mainly used for car paints, snow, or any glittering effects, really. And then, in addition to all that, a slab can have a specular lookup table asset plugged into it, right here with our specular profile if you actually select the slab itself. So this allows us to kind of create our own uniform tinting for the slab based off of light angles. So imagine kind of an iridescent pearl. It has rainbow colors depending on which way you're looking at it, or like an oil slick, or even kind of complex car paints. We would be able to create a specular profile here to kind of create that custom um, color to angle reflectivity color, which can be really useful in depending on what you're working on. So all these things here were dealing with what the interface of the slab was doing. So this part right up here. But we also have the kind of albedo, so the diffuse albedo, and this SSS, MFP, MFC scale, and phase anisotropy. And these two work in conjunction for the slab's medium. So that is going to be kind of all of this material kind of right here in the middle. This is the medium, right? And this is what the material is. Is this wood? Is this flesh? Is this the inside of a grape, right? Imagine you have like a grape. You have kind of the interface being kind of the peel outside. The medium is going to be kind of the fleshy insides. So the medium, composed of a whole bunch of kind of particles inside of it. And some mediums are going to have kind of really dense particles together. Other medium is going to have, it fairly spread out. And depending on how kind of spread out these particles are, this is what's going to be defining that MFP, or the otherwise known as the mean free path. So the mean free path is essentially the distance from, say, the interface down to one of these, particles of the medium. This here is essentially the MFP. So this is the mean free path, right? So it's this distance right here. And the value that we use in our mean free path is going to kind of work in conjunction with what our diffuse albedo is doing. So the more we increase our diffuse albedo here, the more milky it will appear as light is absorbed by the medium's particles instead of bouncing back, and the more kind of mean free path we increase, the more we see through the object. So if you kind of think about it here, right, if I have fewer particles for kind of my light rays to hit, then that light ray is going to kind of just go straight on through to the medium. It's not going to hit any particles along the way, and then it's going to kind of continue out this way, right? But these particles are also, or these light rays are going to eventually, at some point, probably enter into the interface, come in here, hit a particle, and then kind of bounce back out this direction, right? And this right here is going to be our scattering event. So you may have heard the word subsurface scattering before, right? Subsurface scattering. And it literally means just that, right? It is light that is coming down. It is going subsurface, so it's going below the surface, below the interface, hitting a particle and then scattering. And sometimes that light ray will bounce back. Other times the particle is going to have basically an absorption event, right? And this absorption event is going to yeah, basically just absorb the light and prevent it from kind of going all the way through. So this is a subsurface scattering event, and then this would be an absorption event where the light is actually absorbed by the medium's particle. So these two things kind of work in conjunction. We have the albedo and the mean free path. So when we are talking about the mean free path, just remember that it is essentially the distance between entering into the medium and when it finally hits a particle. And the longer it can go without actually hitting a particle, the more see-through it's going to be, because the light is essentially going to be able to travel all the way through that medium onto the other side. So, you can kind of think of that's going to be see-through. The more medium that there are, right, the less it's going to be able to kind of have light rays that manage to get all the way through without hitting something, right? These are all going to bounce back in some direction, some might get absorbed, but then this one might kind of make it all the way through, right? So fewer of them light rays are actually going to make it all the way to the other side, therefore it's going to be less transparent, if you want to kind of visualize this. So, the medium is described in terms of the mean free path, which is this distance here, the albedo, i.e. the overall medium kind of reflectivity, the thickness of this medium. So the thickness is also going to play a factor. So basically just, how thick this part is itself. And the what we'd call the phase function anisotropy, which describes the scattering directionally when hitting a medium's particle. So which way it goes, what wavelength gets changed. And as I say, the more we increase the diffuse albedo, the more kind of milky it's going to appear as light is absorbed by the medium's particle instead of bouncing back. And the more mean free path we have, so the greater this distance, the more see-through it's going to become. And just note that the MFP is expressed in meter. And these values are kind of very important that we understand. So if I start putting in a value of, say, 1 here, well, that's going to be representing 1 meter. So chances are I need to go pretty small if I want to get a value that's going to kind of work in conjunction with my diffuse albedo. So diffuse albedo and my subsurface scattering MFP, MSC scale, and phase anisotropy, these are all going to be very useful when we are mixing our materials together. And this is going to be primarily useful when we're going to be using what's called a vertical mix. So we have a few different mixes that we can use. And the vertical mix, so if I just type in substrate, you can actually see all the different building blocks of substrate. It has, we have operators, which are going to be kind of our mixing tool set, which allows us to kind of arrange materials in a certain way, either on top of each other or kind of masked out by an alpha. We have just some helper nodes that are going to allow us to convert our kind of current workflow into this new substrate workflow, which uses kind of F0, F90, diffuse albedo, subsurface scattering, mean free path, etc., without having to kind of redo all of our maps that we may already have created. And then we just have a few other things such as building blocks, substrate BSDFs, which are going to allow us to have represent most surfaces, like simple plastics, to complex ones like water and hair. We can use different bidirectional scattering distribution functions. And then And then building blocks are essentially just a set of material functions to provide translations for common use cases, such as converting Unreal Engine 4 default shading models into the substrate coded layer, for example. Looking at mixing, we have these operators here. We have a number to work with. So the one I was just referencing here is this vertical layer. And this is essentially going to put one slab on top of another slab. So this is going to mix it based off of this property that we plug in here. And this can either be a scalar value, like so, or it can be a texture map that we plug in for a grayscale image, for example. And this is going to create a layering system that is going to go, think of it like a jawbreaker, or maybe like a block of ice surrounding a stone. The ice would be the top layer, the stone would be the bottom layer. And you can define how much ice it is from the stone to the top of the kind of ice layer. So this would be a vertical layer, and this would make heavy use of our subsurface scattering mean-free path properties. The other operator we have is going to be this coverage weight, and this is essentially just going to act like an alpha. And again, you can use textures or scalar values. We also have this add, and this one is mainly it's going to combine two slabs together, but it doesn't take energy conservation into consideration. So this means you can use it to kind of art direct, but it really should be avoided if you're trying to work in a true PBR workflow. But if you're working in kind of a stylized approach and you want to combine a couple of slabs together, then this could be something you can use to kind of, art direct yourself into what you want it to do. And then I have this horizontal blend, and this is going to mix two slabs together, represented by kind of a foreground and a background. The mix input does basically a lerp between the two, where the background represents 0 and the foreground represents 1. You can also have lerps, or ratios of, say, 0.3 of the background, 0.7 of the foreground, etc. Or it can just be completely one material or the other. So think of it as if you have two layers side by side that are being mixed together. So this is what we're going to be working with today to kind of solve a common error that we would often see when working in a PBR workflow when we had, part of our material being, say, a painted, part of our material being painted, and then maybe we scratch it down onto the bare metal underneath. We're essentially going from a dielectric material, the paint, to a conductive material, the metal, underneath, and we would often see an error when that happened. So let's just take a look at a common texture authoring program, Substance Painter, and I come over here and I have kind of just a corrugated, sheet metal, and I have some paint kind of on here as well. And it isn't as evident here in Substance Painter, but you can still see it as I kind of get real close up to some of these damaged areas here, where I have the paint transitioning onto the metal. I have kind of this halo effect kind of going all around it. So if I were to take this texture as it is right now, where I have my metallic map here being masked out for my paint, roughness, base color, all the typical stuff, and I export this, and I've just choose the kind of just Unreal Engine packed. I've just adjusted the name of it so that I can have just the texture set. So my file names look a little bit nicer than what the default is, but essentially it's the same as kind of doing a packed texture. There's nothing fancy about my export settings here. And I'll export those and I'll bring them over into Unreal Engine. So I'm going to create a new folder here called Textures. And I will bring in those textures here. I'm going to just drag them in. And right away, so whenever we bring in new textures, I want to make sure that they have been imported in with the correct settings. So I'm going to open up this ORM map, the occlusion roughness metallic, and sometimes if it's a purplish color, it may think that it's a normal map, so that's the first thing that I want to check. It didn't. It would have said normal map if it was, so just left it there. So you have two options. You can set this to masks, or I prefer to just leave this as the linear color. So I just disable the sRGB. So my color profile when I'm working with the texture node in the material editor is going to be classified as a linear color instead of a mask. Just personal preference. I don't believe it has any performance implications anywhere. Just keep it consistent across your entire project. So with those imported, I'll go ahead and just save those. And I will create a material with that. And I'm just going to bring them in like so. And I'll just hook them up to this kind of helper node, which is already hooked into my front material of the result. So I'll plug my base color into my base color, my metallic into my metallic, my roughness into my roughness, and my normal into my normal. So, with this helper node, I've basically just done the same workflow as if I was using a legacy material in Unreal Engine. So I'll save this, and I'll just go ahead and apply this to a cube or something here. So I'll just scale this up. And I'm just going to assign the master material to this. I'm usually quite against assigning master materials to this, but for time's sake, I will leave it like so. Okay, so now when I look at this, I can see that I'm getting kind of this kind of white halo kind of all around where that metal and paint material meet. And it's going to be more prevalent on areas where you have kind of like damage. You can kind of see I have this kind of, halo kind of occurring everywhere. And the more pixels that this is taking up, the more prevalent it's going to, the more noticeable it's going to be. So if this is a larger asset like so, I'm going to notice that, even more, this kind of white pixel. So this is a problem with kind of any PBR render that we have been using up to now. But the way that Substrate works is it allows you to have different material domains per pixel. So each pixel can be identified as either metallic or not, compared to having kind of the entire model make that differentiation. So I'll move this over like so. And the way that we set up kind of that system isn't kind of as straightforward as you might think. So I'm going to just rename this substrate example to substrate example legacy. And you might think, okay, well, maybe all I need to do is use some of the slab in order to make this work. But we'll see that this doesn't work either. So substrate slab. So I'm going to get rid of this, and I'll drop down a slab. And I'm going to plug this directly into our front material so we can see it show up. I'm going to bring in those same textures. Like so. And I have a diffuse albedo and F0, F90, so I don't really have the same kind of metallic inputs that I was expecting. But this is where those helper nodes are going to come in. You can see here I have these helpers, and these some of these helpers here are going to let me convert maps that I might already have into the parameters that the substrate is expecting. So substrate metalness to diffuse color F0 is going to take a base color, and it's going to take a metallic map, and it's going to convert that into diffuse albedo and an F0 for me. So that's going to be super useful to kind of use the maps that I'm already have set up in my texture authoring programs and be able to use them. So I'll just hook up my roughness to here and my normal to here, and I'll try applying this over here, and I'll see that I didn't really get the result that I wanted. I'm still getting kind of this halo around the where the paint goes onto the metal. So kind of what gives here? Well, the way that this is set up, through this one texture, is it's not separating the two materials. So it is kind of still just giving me the same error that I'm used to. So I have to try and kind of approach this kind of texturing with a little bit different mentality than I'm used to. So I essentially want to export out just a clean copy of my aluminum metal part, and then I want to export out kind of a painted version of that. And I'm going to be using these channels here to define where the paint should show up on top of where this aluminum should show up. And I'm getting this kind of corrugated effect here because that was baked from a high poly and low poly. So that's going to be showing up kind of on both of these layers, which is great for kind of my case. It could be that I just want a flat paint as well, and we'll take a look at that down the road. But for now, I kind of want to have both the normal maps showing up on the paint layer as well as this kind of brushed aluminum as well. So I'm going to go ahead and just export out a copy of this metal part. And I have my export settings set so that I can just have the texture set into the name. So I'm going to just kind of rename my texture set here, just be metal, and I'm just going to export this. So I'll just set this to 2K render, and I'll go ahead and export that. Okay, so that's metal. Now I'm going to go ahead and just export out my paint, but I just want to export out a version of the paint that is kind of a full texture here. So I'm going to just look to see what is masking out my paint right now. I'm just going to disable that on one of these layers. And again, this isn't the only way that I can kind of approach this, but this is how I'm approaching it for kind of this situation right now. And I'm going to rename this to paint so that it makes my texture name look nice and I can tell it apart. Great. Now, what I need is to have a mask that I can use in Unreal Engine as well. So as I was kind of working on my layers here, I have this and this layer, I have this and this layer. I want to kind of keep track of anywhere that I'm applying this paint. So what I did was I just created a extra channel here that I just called paint mask. So I just created a new channel, went to user channels, and just gave myself an extra user channel, which I just called whatever I wanted it to be. In my case, paint mask. So, and then I just left it as a linear 8-bit image. That would essentially just be a grayscale image. And whenever I'm laying down something in my mask here, I just wanted to make sure that I had that paint mask channel enabled. So it's going to also paint white into that paint mask. This one doesn't have it because this is just affecting roughness. So now that I have that, when I go to export it, I can export textures. Yeah, I can create an output template. In my case, I have one here called masked, where I just took my user one and created a kind of grayscale image and just plugged that in there, right? I called it paint mask. Sometimes I just call it extra, depending on how many of these channels I'm actually using. But essentially, I just want to export out whatever I've stored into that paint mask channel that I've created. So with that, I'll just set it to masked, and I really just need to export out that single channel. I can see that's giving me a raw linear 8 image, so that's great. So I'll just export that. Make sure that my layers were enabled, great. So now I have a mask that I can use when I'm in Unreal Engine. So if I take a look at what my textures look like now, I have my metal using the same kind of format of an ORM, occlusion, roughness, metal, a normal and base color. I've done the same thing for the paint, and then this is just going to define where that paint layer should actually show up on top of my metal. So I'm going to import all these textures into Unreal Engine, and right away, before I kind of move on to anything else, I want to just make sure that things have imported correctly. So I have my metal ORM, and I can see that, because this is kind of a bit purple, because it's got my ambient occlusion, or my metal map here, and it's got my roughness map in here, and it's got my occlusion in this channel. It's kind of looking a little purplish, so it kind of thought it was a normal map. It's not though, so I need to make sure that I just set this back to a color, and I'm going to just leave sRGB disabled because these are all masks. And I'm going to do the same thing with my paint ORM. Going to just make sure that I disable sRGB because I don't want any gamma correction applied to my mask that I'm going to be using. And then this mask, black and white, it shouldn't have any gamma correction, so I'm going to just disable sRGB. Great, now that all my textures have been imported correctly, I'm going to go ahead and just hit Save All. And I'm going to create the material that is going to not have this halo effect error on it now by mixing these two materials together. Okay, so I'm going to create a new material here. So just right click, create a new material, and I'm going to just call this Substrate Mix. And I'm going to get rid of this helper node there, and I'm going to drop down a slab, and I'm going to import in my textures for my metal base, my paint base. Bring these down here. Okay, and I'm going to hook this up just as I did before. So I'm going to use my diffuse to F0, or sorry, metalness to F0. Oops. So I got my base color in here. I got my ORM map here. So that's going to give me my diffuse in F0, which is great. And I can go ahead and plug in my normal, and I can plug in my roughness. And this is going to set up kind of that metal material. And then I'm just going to add in another slab down here. So we can have multiple slabs in our material depending on what material we want to kind of build up. So I'm going to do the same thing here. I'm going to just grab this metalness to diffuse albedo F0. Hook these things up. Hook up my normal, and I'll go ahead and hook up my roughness here. So with these two materials kind of set up, this is my paint and this is my metal, I can then mix them together through the use of these operators. So as we looked at before, when I want to have kind of two materials kind of side by side, mixing kind of together, I want to be using a horizontal blend. And as I mentioned, this is essentially just going to be lerping between whatever I plug into the background and whatever I plug into the foreground based off of this value that I have here. So if I plug in my metal here and I plug in my foreground paint here, plug this into my front material, I can see it kind of showing up 50% of the background, 50% of the foreground, and that is simply because that's what this mix kind of defaults to. But now if I plug in that paint mask that I exported, I can go ahead and plug this into my mix. And now I'm going to have this kind of paint only showing up in the areas that I had masked out the paint in Substance Painter. So if I save this, and I apply this to a third cube here, and apply that, now I can see that I'm not getting kind of that same white halo effect that I was getting here, right? Any of that damage is either going to be the damage, or it's going to be the painted material, or it's going to be the metal material, right? So all of that kind of common issue that we were seeing all the time when we were transitioning from a dielectric to a conductive material is no longer happening on a substrate material when we are using this substrate horizontal blend operator. So this mix here is kind of taking care of what material domain is going to be applied to what pixel. So I get really nice clean results, which can be super useful if you are working on, say, a painted tank or a weapon that might have some paint on it that's scratched down to the metal that's underneath. I no longer kind of need to worry about that hazy white pixel effect that has been in PBR based off of our current application. So that's really nice, and this is going to be a use case for this, but it does kind of change our mentality and our thinking about when we are working in a authoring program such as Substance Painter, keeping track of maybe where I want this material to be versus where I want another material to be. And I've just used solid colors here, but depending on if this is blue and this is pink or whatever, right? The base color is going to pick up that. All I'm really after is where does this material type show up? I'm not really interested in what the roughness is doing, what the base color is doing. I just want to know where does it show up, and I want to keep track of that through probably a custom user channel, which you may not have thought about using or have much experience using, but it basically just allows you to fill in anything you want into a channel so that you can export it down the road. So I have my normals and ambient occlusion and everything baked into kind of where this shows up. So I wouldn't be able to say tile my aluminum kind of differently than the paint right now. So this is kind of a little bit baked in. But if I'm using, say Megascans materials, maybe I want to just have a metal tiling texture, and I want to have some scratches on it, and maybe I want to have metal as a base, some paint on top, and some scratches on top of that. So I'll walk you through kind of an example of doing that as well. So I've just gone into Quixel Bridge, and I've downloaded a few Megascans here. I've downloaded this wall paint detail surface, and I've downloaded this old metal panels surface. And then I've simply gone to the imperfections section here, and I've just chose some damage or some scratches that are going to kind of just give me something to peel away some of that paint. So I've downloaded and added those into my project here, and I'm going to go ahead and just create a new material here, and I'll just call this Megascans horizontal mix. I'll get rid of this. And again, I want to kind of just approach this the same way as I approached it when I had textures authored from Substance Painter. And I want to just mix it with two slabs. Now, when you import in a Megascans surface, it does, provide you with a material instance already for it, right? If I open this up, right, I have a material instance here, and this is kind of all set up for me. And if I want all of these controls kind of automatically, I could come to the parent and I could try collapsing some of this stuff into a material function and then importing that material function into here. But I'm not going to kind of do that. I'm just going to kind of build up a new material that has controls built in here. So I'm not going to go and have all the same material properties that are here, but I absolutely could just kind of build up these same properties if that's something I want. I'm going to set up a few controls here just to kind of explore this idea, but I can take this as far or as short as I want. So let's go ahead and just bring in the textures. So I'll bring in my paint textures first. This is the normal. This is the, I believe it's an ORDP map, which would be occlusion, roughness, height. So with my wall paint, I don't actually have a metallic map. So if I use this same Metalist F0 color here, yeah, I could just plug this in. And let's just kind of view this as I work. So I could just plug in my base color, and then I could just plug in 0 into my metallic, right? And that's essentially going to do the same thing. This is not necessary, but it can help keep me organized as I'm working. For my ORDP, I'm going to just plug in my roughness, and then for my normal, I'm going to just plug in my normal. Great. And then I'm going to do the same thing with that old metal materials. So I got some metal panels here. This will be my base color, this will be my normal, this will be my ORDP. And I'll do the same thing. I like to kind of just keep things organized here and consistent. If I'm not too worried about performance at the moment, I'm okay with it being just consistent and clear, even if it is a little redundant. Especially as I'm learning how to do things so that when I come back to this at a later time, I can have a clearer idea of what's going on. Okay, so I got my two materials kind of set up here, and I want to just approach this the same way by adding a horizontal blend. And I will put my metal as the background, I'll put my paint as the foreground, and then for my mix here, this is where I'm simply going to be using one of these kind of scratched textures. And this one looks fine. Looks like I have this in my red channel. So I will kind of pull this data from the red channel, but it's always going to, this isn't going to work for every kind of imperfections that I pull down. Sometimes it doesn't have anything plugged into the doesn't have a metal into the redness channel. So just use something that kind of makes sense for your textures or keep it consistent so that you are always pulling it from the same channel. But I'm going to go ahead and just grab this, and I'm going to just plug in the red channel here, which is what has my which is what has the scratches in it. I can see here that, this is the white is showing up here, and I kind of want to reverse this. So I'm going to go ahead and just add in a bunch of parameters here so that I'm not simply working off of a master material, but I have the ability to control some of these elements that I want. So for this, I'd like the ability to basically change all my textures. So I'm going to convert this to a parameter, and I'm going to just call this mix texture. I'm going to do the same thing for these three. And just call this T1 base color. Call this T1 ORDP, I believe. And then this will be T1 normal. I'm going to just plug all these into a T1 group for texture 1. I'm going to plug all this into a mix group, and I'm going to do the same thing over here. So I'm just going to pause this as I jump ahead. And I've labeled these into parameters now, and I realized this texture 1 here, actually, I do want this to be metallic. So I'm going to just set that metallic to 1. So now we get kind of this metallic, because when I work with Megascans assets, they don't have metallic maps. That's why you'll see kind of in Quixel Bridge, most of the metal objects are covered in rust or they have a layer of dust on them, is to kind of avoid this issue of transitioning between a metallic to a non-metallic asset. So, but this is metal, and it's I can kind of see the raw metal, so I want to kind of have that there show up as metal. So with this mix texture here, I'm going to go ahead and just add some controls to it so that I can kind of punch out some of these details a little bit more. So I'm going to just add a multiply node to it to just give me a bit of a balance. And whenever you multiply something, leave the default value as 1, because anything multiplied by 1 is simply going to be its original value. And I'll do the same thing with the power node, where I'm going to just promote this to a parameter so that this can essentially work as a little bit of a contrast. And I'm going to add a static switch parameter, which is just going to kind of invert my mask, just in case I need that. So I will do a 1 minus here. If this is enabled, it's going to invert whatever I had there. If it's not enabled, if the value is not checked, it's not going to invert it. Okay, so this just gives me a little bit of controls to define where these scratches should really show up and how detailed they should be. So I'll set my default value for my contrast to 1 as well, because anything to the exponent of 1 is going to be the original value. Great. So I'll hit save, and I'll turn this into a material instance. Just in my Megascans horizontal mix. So I'll make this into a material instance, and I will call this scratched painted metal. And I'll go ahead and apply this to another cube. So I'm going to open up my metal here. And it looks like I forgot to group some of my parameters. So I'll just do that before I forget. So all these parameters here are simply going to go into my mix group. That way I can keep everything organized. Okay, so right off the bat, I kind of want to just invert my mix, right? And because my scratch metal here, like this isn't just 100% black, I want to kind of just push up some of these values in my mix. So if I adjust my balance here, I can kind of push that farther so that I'm essentially almost doing a levels to my channel. Right, so I have this contrast. I'm just going to kind of play with this to kind of eliminate some of that kind of fall off with it, get some more of these scratches here. Right, cool. So I'm getting some of this paint kind of removed and it's exposing the bare metal underneath. But if this is supposed to be kind of a corrugated metal, some of that underlying normal map of that metal panels should be showing up here too. So, that may be something that I want to have happen. Maybe I want the normal map to be completely covered up at other times. But it is a property that maybe would be useful. And in this case, I think it'd be quite useful. So if I set my balance to 0 here, I can see what it looks like with just the paint on there. So I probably want to have some of those normal maps underneath show up. So I'll just come back here. And I have my normal map coming in from my metal. And I have my normal map for my paint. So I want to simply kind of combine these two things. And whenever you want to combine normal maps, you can use a blend angle corrected normal. You can't simply just use a multiply or an add node or anything like that because we're working with XYZ data. So I will take my corrugated metal as the base. I'm going to go ahead and add my paint normal as the additional normal. I'm going to run this into the normal of my second texture. And I might not want this to show up all the time, so it'd be really nice to have a control for how much of this kind of base normal should show up. So I'm going to just add a flattened normal node into this so that I can have some control. And I will just call this underlying normal. And I don't like working 0 up. I like to say that, how much of this do I want to actually show? And if I want to decrease my underlying normal, I want to bring this down to 0. So I just like to add a 1 minus here so it works a little bit more logical in my brain. And then I'll go ahead and add this into a T2 group so that everything is going to be nicely arranged in my material instance. So if I bring this back up, I now have this T2 parameter for my underlying normal. So if I come back here, I can say that, no, I don't want that underlying normal to kind of show up at all. Or I can say, yep, go ahead and pop in that normal here. So I can see when this is painted, and I can use my my mix and my balance here to kind of really scratch away at it. Right, and I would just kind of continue this on and kind of build this up as I want some of these properties. If I want the ability to kind of tile my scratches here, right, I can use all the same techniques as I am accustomed to when I'm not using substrate materials, right? I can take my UV coordinate system, I can multiply it by a scalar value, right? Plug that into my UVs, and now I have the ability to kind of tile my mix. Right, so a lot of the same kind of controls and formulas and everything that you are accustomed to from working with your legacy material creation, all those skills are going to kind of transfer over. You may just need to, add in a helper node along the way if you, for example, have a metalness map and you need to start adjusting. The F0, for example, or the F90, if you want to have a little bit more artistic direction, right? And because these are all kind of textures here that have been exposed, right, I could try popping in different ones, to get kind of different effects here. But this is just a simple way to kind of show how we could be using horizontal blends to blend between a metal material and a non-metal material. And again, we're not getting that kind of same halo effect that has kind of plagued PBR rendering up until now.